Welcome. I'm doing a string of videos for the Tronxy X1, and I've done some build videos. They're not like reviews or anything of that nature. It's really just me building for my daughter. And I've started coming up with a couple other videos that I think may be helpful for some issues that I came into when I was running through the setup process, the calibration. So I just did one for nozzle heating issues, and you can check that out. There'll be probably a link here. I'll put it somewhere, and down in the description. So this one's specifically going to be related to part cooling. What I noticed after I got some of the other heating issues kind of stabilized was, like any printer that doesn't have part cooling, you get a lot of sag. The whole point of part cooling is you're laying down a molten layer or bead of plastic, and when you do that, it's going to of course stick to the layer below it. But what starts happening is, if it doesn't get cool quick enough, it's molten, and the hotter you run the nozzle, the worse it is, and everything will start drooping and dropping. One way to describe that is, you can kind of see up underneath here on some of the layers there, like right in here, you can see some droopage. That is because it's molten and it isn't really sticking, and there's nothing, or it's not. In this case, it's an overhang and it has nothing to stick, and because it's just so soft, it just droops down. So most 3D printers have part cooling fans. The cheaper ones, that's one of the reasons they're cheaper, is that they reduce some of the options that are out there. Now in this case, you can add it. And that's the wonder of these kind of printers. So I wanted to add a part cooling fan. I went to Thingiverse and I came up with a couple options. Why reinvent the wheel? They had a couple really good options, and one of them, what I basically did was, I had this was the part cooling fan. This is where it was designed to mount, and it mounted with one screw right here. The issue that I had was that over time it was starting to sag a little bit because it's a PLA, and I didn't want to print it with PETG because nobody else is going to be able to print that unless you have another printer. So it was dropping down below the nozzle and it was snagging. And then on top of that, this fan, you can see the size of that fan versus the one I ended up using was so large that it had tons of issues. And so that's what ended up making me get into the heat management video, which I'll have linked below. So what we noticed was, because this fan was so big, I was cooling down the whole hot end, because what was happening, as you can see, this piece is the outlet of the fan, and the idea is the nozzle is sitting right here. But the problem is the way it was all set up, too much of this air was actually getting around up into above the nozzle into the actual block. And I was blowing, theoretical in this case, room air, which is cold air on the block. And that was what was really starting to show the heat issues that was from the other video that I did. And more or less, it wasn't able to maintain a stable heat, and because of that, I was dropping, at one point I dropped like 15-20 degrees, to the point where it was barely printing anymore, so I had to stop everything. So anyway, so there was two issues that I really ran into. One of them was because of the size of the fan, and the other one was the heat management side. I kind of stopped everything I was doing with this, went and fixed the heat management issue, which was the other video that'll be linked either up here or down in the description. And then I came back to this one. And then I didn't like it for a couple other reasons. Again, nothing against the design that was made. It was very simple, which was its point. One screw connection. But Just didn't like it. So then what I did was I did this one. So this is the one that I ended up going to, and you can see it was printed in vase mode. There's a small flaw here which I won't even get into, but more or less it was a failure on my part. I snagged the one of the clips here that was on the bed and it broke it, but it still works well. But because I had too much fan, I went ahead and bought a little 30mm fan, and this one seems to be working really well. It's smaller, it droops down below here, and it's more controlled. It's very, very focused just below the nozzle. It doesn't drop, or just it blows air just below, and it doesn't drop below the nozzle's level, and it just works really, really well. And I've had no issues with it at all. And as you can see, I put a connector in to allow it to change, and the big piece is it just runs a wire down into this. This is my Octoprint, and it goes in here, and inside here there's a connector. So that cooler I actually liked. It has a nice small fan. It seems to give plenty of cooling. I haven't had any really major issues since I went to that, other than when I kind of broke it a little bit, but eventually I'll print another one. So after that, what I did notice though was I was getting some under extrusion, and what you can kind of see it is I was seeing different issues on the print, and there's lines, and there was just some indications of under extrusion, which means we weren't laying enough plastic down to actually print correctly. So the next thing I needed to do was calibrate my extruder. Since we don't know how much information or how much plastic's coming out the nozzle, we have to figure out a way to make sure it's the right amount. And the easiest way to do that, there's a lot of videos in Google or on YouTube to show you how to do it. Tom has a really good one. I've used that one and a couple others. If I remember correctly, or remember, I'll put the link down in the description. You basically, in a very short story, you mark your filament where it goes into the extruder. You mark it out 150 millimeters, and you'll go into your control software and you actually manually tell it to print 100 millimeters of filament. So it'll extrude in 100 millimeters, and then you measure, and in a perfect world you'll have used 100 millimeters, so you'll have 50 millimeters left because it'll have used 100. In my case, I was at like 82, so I was not putting out nearly as enough filament compared to what it should have been. And what you do with that is, once you've determined how much you either are over or under extruding, you're going to change your E steps or your extruder steps per millimeter to make sure you get the right amount. So if you're under extruding, that means that you need to have more steps for your stepper motor to equal 1 millimeter of length. So in my case, they come in at, I think 90 is what they all come in at, 90 steps per millimeter, and I had to go all the way up to 110 to get the right amount. So once I did that, I was extruding in the ballpark of 100 millimeters, 400 millimeters, and I got some better prints. But somewhere in the midst of all this, I decided to shortcut, and I don't remember exactly where, and instead of, because I use Simplify 3D, most of you will probably use Cura or Slick 3R or something like that, because Simplify 3D is $150 software. You don't really need it. You don't want to get software that costs more than your printer. But I use Simplify 3D, and I grabbed a profile to shortcut so I didn't have to actually set up the printer and set up everything. And when I did that, the profile I got off of the Facebook group, which I'll put a link to down below, it's actually a really decent little group, not super active though, but anyways, I got the profile from there, and they had a setting in there. You got to be aware of the internet, and whoever had this profile, for whatever reason, had a setting in there that messed up the retraction. So what retraction is imagine you're pushing in the plastic into the hot end, which is coming out like a glue gun. And when you're going to stop and you want to go to, say, another place or raise up to another Z height or whatever you are going to do, you'll want to retract your filament, because if you don't stop feeding even if you just stop feeding, there's pressure in the of molten plastic in the nozzle, and it'll ooze all out, and you'll get lines, and it's called stringing, and it just looks really bad. So they have what's called retraction, where it pulls back and then goes back forward to continue printing. In a perfect world, it's going to pull back and go forward the exact perfect amount, so you never see a stop. What ends up happening is you'll see a print. This one is lined out, and I don't know if you'll be able to see it or not, but there's actually a line, and you can feel it. I had this one aligned so it was put them all in one piece, and what you'll get is little pimples, where it's little bumps of plastic, or the opposite is you'll see a lack of plastic. Because what happens is when it goes in, it'll start continuing on, and if there's a pause and it gets to the end, and if it stops and then goes up, or stops and then goes to move, if there's still stuff coming out, you'll get a little block of filament there, a little bump, a little puddle, if you will. This profile had a setting in Simplified 3D where it pulled back, say, 4 millimeters, because I have these are Bowden systems, so you're going to have to go more than what's a lot of your direct drives and stuff. They'll only go 1 to 2 millimeters or even less. But this one is 4 millimeters. We pull back, and then when it went back, it had a negative 0.5 millimeters. So every time it retracted, when it went forward again, it stopped a 0.5 millimeter early. That didn't really become obvious on the regular prints, because I did like these, I think were the good ones. Yeah, these were all prints that I did, and with that setting in place, I believe, and they look okay. Well, somewhere along the line, I think it was right after this is when I changed it, and this is all of a sudden what I started seeing. Not exactly pretty. And what it is you'll notice it actually printed fine, very decently actually, up until it got to the windows and the arches, and then it destroyed itself. Well, what happened was, because there were so many start and stops, every one of those little tiny little short prints caused it to retract an extra 0.5 millimeter. Well, it was walking itself backwards to where it wasn't extruding plastic. I managed to actually manually keep pushing plastic in there to get it to finish, so it could finish off the print, which I'm actually impressed that I was able to do that. But part of that, where I also noticed it, was in this, and you can see in this area right here, it's almost holes everywhere. You don't actually have anything that the plastic's not fully extruded compared to like all the rest of the wings and stuff. And these are all printed on the Tronxy. So that was also in the back of my mind. And you see more issues right in here. So there was a lot of issues going on, and in the back here, you can see that there was missing filament. And once I figured that out, it was way simpler, and everything at that point kind of came together, and I didn't have any more issues. So at that point, the nozzle heating all came together, the extruder, the filament, now the retraction, and everything kind of came together, and I started finally getting the prints, because everything was almost good prints. So anyway, so there you go. That was why you need part cooling, what I did to get through it, what caused me to start looking at it, and what I did to fix all my problems. And that's pretty much it for part cooling. I appreciate you stopping by, and hopefully I can help you a little bit. If you had any questions or any feedback, put them down in the description below, and you have a great day and happy printing.